what you are supposed to do in today's lab session. So I'll be waiting for 2 minutes for everyone to join. Am I audible to you all? Okay. Okay, I suppose most of you have joined the lab. So in today's lab will be about clustering algorithms. So in the classroom, I suppose you have studied about two main clustering algorithm, that is k-means and hierarchical clustering, right? I suppose you know the theoretical concept behind k-means clustering. So clustering is an unsupervised learning algorithm in which you will be trying to group the data that you have based on the similarity between the data set, right? That is what you will be doing in the k-means clustering by finding the distance between the centroids that are given to you and from the point that are given, the data points that are given to you. Okay. So in the classroom, you already lecture notes have been uploaded as well. So what you are supposed to do in today's lab session is two files are given to you. One is for k-means clustering and one is for hierarchical clustering. And just a minute. And sir has also mentioned in the class comments some of the tasks that you have to do as a part of today's lab session. So what you're supposed to do is study both of the lab files that is given to you, that is k-means clustering and hierarchical clustering. Study the behavior of both of the algorithms and also refer through the lecture note that is given to you, that how both of them are working on the data set. And then based on the implementation that is given to you, so in this particular k-means clustering file, if you open, this clustering algorithm has been implemented by taking some random sample of data set. By using that function make blobs, using that function you can make random samples, and based on that the clustering algorithm is implemented on that random data set that is created. But now you have to implement the same clustering algorithm on a real time data set, that is iris data set, for example, or any other data set for diabetes and iris data set. So you have to perform the implementation, the same implementation you have to perform on both of this data set. So the first task would be, first go through the k-means clustering algorithm and go through the class node that is given to you. Study both of this class node as well as the k-means clustering algorithm implementation that is given in the lab manual, and try to implement the same on the iris dataset and diabetes dataset. Is it clear to you? And later, after performing the k-means clustering on this particular dataset, you may proceed with hierarchical clustering. Okay, I suppose the lab instruction is clear to everyone. Yes? Yes or no? Okay. Yes. So meanwhile, while studying this, while performing this, so I'll be giving you no, Matplotlib is a function that is used to make a data set. So here, if you see, some of the parameters are given to you, such as samples, cluster, centers, and features, and everything is given to you. Based on that, it will create a random data set by itself. Okay, that is what it is doing. Fine. So what you're supposed to do is try for this, study the data, study the program that is given to you, study entire implementation part for the k-means clustering, and try to implement this in for iris dataset and diabetes dataset, right? Okay. And later on, after performing the same for k-means clustering, you have to proceed with the hierarchical clustering and study the behavior of both of this clustering algorithms. So I'll be giving you 30 minutes or something to study both of them and start with the implementation of k-means clustering. And meanwhile, I may ask any one of you, and sir will also be joining in a short while in the lab. So we may ask any one of you to show your implementation, but you are not supposed to leave this particular meeting based on this particular instruction, right? Your evaluation will be based on this also. So make sure that you are, if you have joined the classroom, you are here till the lab ends, and whenever you are asked any question, you are ready to answer it. So you are not supposed to make any excuses that your internet is not working, or you are supposed to be present with your internet and your laptop and everything in whenever you join the lab session, right? It is expected from you because this is a lab session, so you are supposed to be present with all the things that are required to perform the lab practical. So make sure that you are present with all the things, and after 30 minutes we may ask any one of you to present and share what you have studied, went through while you went through the lab manuals and lecture notes. Fine. So is the instruction clear to everyone? Okay, so start with the okay, so everyone start with the start with this, and meanwhile, if you are facing any difficulty, you may ask in the chat box, or you may unmute yourself and ask, right? Yes, on both the data set. First start with k-means clustering and implement them on both the data set and then start with hierarchical clustering. Yes, Priyank. So your question is on any one or more than one. So based on the data set, are you asking for the iris data set? Is it? Okay, yes, diabetes. Yes, yes. You have to consider all the columns while you are performing clustering algorithm. Yes. More than one columns you have to consider. That is, you have to consider entire feature, whatever features are present in that particular data set, that all you have to consider while performing it. Right? Is it clear? Okay. Also, regarding an evaluation, I wish to give an instruction that will be starting to check your work, that is you have given in the evaluation one, that is the link that you have shared with us, the GitHub repository link. Will start checking what the work you have done, what implementation you have performed, and still some of students have not submitted their evaluation, the link that is being asked for you to submit. uh, in the evaluation one, the GitHub repository link has not been shared yet for some of the students. So make sure that you do it. Don't take this instruction lightly. You are supposed to submit the link, and this will be considered in the part of evaluation. Late submission of your link will be taken into consideration. So make sure that you keep your work updated from this lab onwards as well. From the lab 8, lab 9, whatever lab work is being given to you, you keep them updated as well, right? It is fine if you do not visualize at this point of time, but if you want to experiment by applying PCA and try to visualize, then it is a good thing. You may try it as well. Okay. Okay. Anyone would like to share what they have studied so far? Anyone? Or anyone who has started with the implementation? Would you like to share? Okay. How to get ready dataset which is passed as parameters in k-means.fit. Okay. See in the implementation that is provided to you. Just a minute. So in the implementation that is provided to you, if you see here, what we are passing is we are passing x as a data dot x fit. We are passing x as a data. So in the similar manner, what you may do in the case of this also, you may divide the data set using the train test split. You can create training data, testing data, all that you may create. So, or what you can do, you can create based on pandas data set. You may create the x data set. You may separate the labels and the columns that is given to you, and you may pass that x the whatever features you are storing in a particular array, or you may store in a data frame, whatever you may use, and you may pass that in the fit function, that is your data set, into the fit function. Are you getting the point? And you may perform some pre-processing steps as well, right? Normalizing the data, bringing them into a particular range and all that you may perform. Are you getting the idea now, Priyank? Or
But
still it
ma'am,
is
this
yes.
is the unsupervised model. Then what is the meaning of taking the targets value?
No need to take target value. That is what I'm saying. Just take the feature set that is given to you. Okay. So what you may do is you may separate the feature set from the target set and take the feature set itself only and pass it into the fit function. Okay. Are you getting the point now?
Yes, ma'am. Okay.
Okay. Yes. Yes, Ronak, you have a question that how do we know the clusters initially? See, at this point of yes, yes, Harsh, all the four features as target, as no, not target features, but as the features of your data set. They are not target labels, but they are features of your data set that you need to pass in your fit function, right? Is it clear? Okay. And Ronak, I suppose you have a question that how do we know the number of clusters initially? Here we have randomly taken number three as the value to generate the cluster. But if you see, if you go through the lab manual once, there is one method. Have you been studied, have you discussed elbow method to find out the number of optimal number of clusters to divide your data set? Is this discussion done in the classroom regarding elbow method? Ronak? Okay, so sometimes what you may use is there is an elbow method already given in your lab manual as well. You may study that and understand that what is this elbow method that is given to you. But we may not know the number of clusters initially. So this is just randomly chosen. One of the method that is randomly chosen, the number of cluster here, that is three. Okay, that is no, but you may use elbow method. You may use elbow method to find out the optimal number of clusters for your given data set. That is what does elbow method do is it try to for example, you may use for example, what does it do is it will there is certain graph. If you see in the classroom section as well, there is a graph of from the distance from the number of clusters, that is 2.53 optimal 2 3 4 5, or you may say a number of clusters versus the score. So here what is yes, in certain range, and here that is celluloid score is being taken. You may take any other score. For example, there is another score as well, which is within cluster sum of square, something like that. If you refer online, within cluster sum of square, something like that is also given. So what does it do? It is for example, it takes number of cluster value, for example 2 3 4 5, any number of clusters, any number of cluster value it takes, and it tries to calculate the distance of the cluster from the within the cluster. Okay, from the for each value of the cluster, it will calculate the sum of the distance between the point and the centroid of the cluster, between all the data points and the centroid of the cluster, and whichever gives an optimal value. So wherever this elbow is formed, for example, here the elbow is formed at 3, so that will be chosen as an optimal value of number of cluster. Are you getting the point? Yes. Okay, so you may use this method to identify the optimal number of clusters. This is one of the methods that you may use to find the optimal number of clusters for your given data set. Okay, so study this one as well, and just let me know. So all of you study this one as well. Okay. Okay, so anyone would like to share the screen? So how far have you reached in the implementation part? Or should I ask anyone, any randomly, choose any random student? Okay, yes, Keval, yes.
Hello, ma'am. Is screen visible now?
Yes, yes, the screen is visible.
Ma'am, here I am taking this here iris data set, then divide it means taking the features and target from the iris data set, then splitting this data set into the training and testing. Then here, ma'am, I have actually facing the errors while visualizing the data set. So that's why currently I have
Okay,
not visualized it. And then I have
yes,
divided into the three cluster. Then
okay,
I am here creating the models. Then here I am finding the
okay,
centroid. Then here label, and here I am predicting the output.
okay. Which feature have you passed? Can you show, can you go a little,
Features
train the
here.
split? Okay, you are passing the features, right,
Yes,
directly?
ma'am.
Okay. So no need to perform, I think, but okay, yes, ultimately, fine.
Ma'am, actually I
So
am
why,
doing because I want to check the accuracy, but for accuracy I need some true value, actual value, and predict
yes.
valid value. That's why
Okay,
I'm
so you can also observe that in what cluster it is being
yes,
means
ma'am. Here,
after
yes,
yes, yes.
this data is into the cluster 0.
Okay.
I am
Okay,
getting out.
similarly for the entire data set you can create for generate. For example, you have predicted for this particular features, right? So
Yes,
in the
ma'am.
features you are passing the entire data set. Instead of that, you may pass only the training part that you have generated, and
Yes, ma'am.
later generate that what is the cluster that it is being separated into, and then you may calculate the accuracy based on that.
What
Okay.
that means here, I instead of creating this hard coded array, I
Yes.
should pass X train.
Huh. Yes, yes, yes. That is what I'm asking. Pass the prediction that you are getting for the X-ray.
Okay, ma'am.
So here, like in the k-means dot predict. Okay, what you may do is, so yes, yes, that is what I mean. Pass the entire X train, and for that you'll be getting a prediction, right?
Prediction.
And then you may compare it with the actual prediction in your
Yes,
labels
ma'am.
that is given in your
Exactly.
data set.
Yes, ma'am.
Okay,
Yes.
okay,
Okay.
fine. Yes, anybody else? So I'll be randomly asking you then. So 1110, Dhruv Patel. Yes, Dhruv Patel, are you there in the meeting? Okay, those who are leaving the meeting, just make sure that yes, yes, Rikin, yes, that it will be noted. Yes, Rikin, share your screen. Okay, data is regression type. Okay, I'll come to that in a short while. It is the same, not getting a good silhouette score. Uh, okay, well, what is the okay, I think the silhouette score is for the elbow method that you are implementing, right? And yes. So how you are trying to relate this to? Yes, yes, Janil, please unmute.
So I'm trying this on diabetes dataset, and
Yes.
so if I'm trying this on diabetes dataset, it is not giving me the good score. So final that seal
Okay.
out score is only that evaluator from which we would see that the results per. I mean the optimal number of clusters we have got or not. But in that
Yes.
for all the clusters, I'm getting like zero point 0.2 or zero point 0.3 only, ma'am. Not more than that. So I applied PC also. Now I'm waiting for the results, ma'am.
Okay.
Because ma'am,
So
the
you are.
output. Yes, ma'am. One
Yeah.
second. Ma'am,
Yeah.
actually, the output is in 214 unique labels. So that's why, ma'am.
Okay. Okay. So that's why you are getting how many clusters that you used? Did
Ma'am,
you
actually,
use?
in seal out score, I'm trying from 2 to 214 because I thought all. I mean, for
Oh.
every output, I should
Yes.
try.
Yes.
So that's why I tried it like that, ma'am.
Okay. So did you get any elbow? Did you get any?
Yes,
Why,
ma'am.
why did
Right
you get
now,
the elbow
so,
value?
ma'am, in elbow I got at 2. So k equal to 2, I'm getting a
Oh.
seal out score of 48, and then all our rest are less than that. That's why.
Okay. Fine. So did you get the elbow at 2? Is it that you are stating?
Yes, ma'am. So can I present, ma'am? So it would be
Okay. Yes. Let
after
me
Rikin,
see.
or ma'am after Rikin does it
Yes,
after.
yes. Okay, yes. Just Rikin present just now. We'll see the error that you are getting.
Okay, ma'am. Thank you, ma'am.
Yeah.
Hello, ma'am. Is my screen visible?
Yes. Yes, yes. Your skin is visible.
Ma'am, while importing this K elbow visualizer, I'm getting one error
Yes.
as everything is running perfect.
Okay. Well, what is the error that you are getting?
1 minute. And this type of error is coming.
Okay. Yes. So Janil is saying that you need to install yellow brick. So you may
Yes,
try
ma'am.
that one.
I did, but it is saying that command not found.
Okay. See, I think in Conda is not one method. You use pip here because it is explicitly for Anaconda. For in that you may use directly just install remove this distribute the yes yeah. Remove that dash c as well. Yeah, now try. Yeah, so this was in with this one you need to use pip as an a way to install, right?
Okay,
Okay.
okay. Yes.
Yes, now try that. Let me know whether you are facing any difficulty. Okay.
Okay, ma'am.
Yes, so Janil,
Yes, ma'am.
yes, share your screen.
Ma'am, is my screen visible?
Yes, yes, your screen is visible.
So,
Okay.
ma'am, I tried this on database diabetes dataset.
Okay.
So this was the plot that I was getting.
Right. Okay. Okay, Ricky. Uh, Fine. Yeah, show me the initial code that you have done.
Yes, ma'am. So, ma'am, in this I have used this PCA PCA for two
Okay.
component. I have split it. I mean, converted that to two components only.
Okay. So you have converted it to two components. Then later on, what you have done. So what is the feature set? Can you show me the feature set that you are passing into the X? Can you
Yes,
show
ma'am.
me X? What is X?
See, ma'am.
Okay, fine. Yes, yes. Proceed. After that, what you have done?
Okay. So, ma'am, after that, I was doing this, and ma'am, 1 second, ma'am. X of 0, I think. Yes, X of 0 and X of 1, I think. No, sorry. Any... 1 second, ma'am.
Yes, yes. X is now. I think a small X you have mentioned.
Yes,
here.
ma'am.
Okay, this
So,
is the
ma'am-
data set. How?
Yes, ma'am.
Hmm.
And
Okay.
what I was telling, yes. So, ma'am, after that, I was doing this on only 2 clusters I am forming right now because I got
Okay.
the best results from them because I saw here that. That's why.
But still, can you go with the elbow method for only 2 to 5 range? Just see that what is
Yes,
the
ma'am.
observation that you're getting.
Sure.
Okay. So you are getting an optimal value at 2,
Yes, ma'am.
I guess, right? Okay, I think this should be fine. But also, what I would suggest, instead of using PCA, can you just try without using PCA?
Yes, ma'am.
Can you just try for the entire data set and also try to do for the scaling, also do the scaling of the data set as well, and before performing for the entire data set.
So,
Can
ma'am,
you try for
scaling
that?
like in 0 to 1 or -1 to 1?
Any so min max scalar, you can use the inbuilt scalar, standard scalar you can use.
Okay, ma'am.
Okay, and try for it and let me know that what is the observation that you're getting.
Yes, ma'am. 1 second, ma'am. See, ma'am, actually, these are the labels like this. So, ma'am,
Yes.
there are too many to be clustered. So, that's why, ma'am.
Okay, but still maybe the distance, based on the distance it will form the cluster, right? So
Okay, yes, ma'am.
since I think this is the Y label that you're getting, this is the Y label, right, in the
Yes, ma'am.
diabetes data set.
Yes,
So I think some of them are at a very small distance from each other. So maybe
Uh,
based on that it will form the cluster, right?
yes, ma'am. These are very
Yes.
near to.
Yeah, nearer to each other, right? So just observe that what is the for the entire data set without using PCA, right?
So, ma'am, this is without using PCA, ma'am.
Okay, so you are getting 2 as an output.
Yes, ma'am.
Yes, fine, good. Now you may try for the hierarchical method as well, and just
Ma'am, is it possible that we get some like by applying something we get good accuracy? I mean, good seal out score.
I am not aware of that as right now,
Okay.
but I'll let you know in a short while. Fine. Yeah. Fine.
Also, I
so
would like to add something here.
yes.
Yes, sir.
So one thing is the data. Well, we also need to look at the data set, like whether the data set is good enough for clustering or not. So if the
Yes, sir.
data set is of if the data set is
Sir, I
reduced
don't
or
think it is good for
clustering,
clustering, sir.
yeah, so that was the idea. Like, so by looking at the data and result, we need to understand what method works for a data set. But in this data set also, if you remove the Y label and select the set of features, not all the features, then maybe you
Okay.
can see some clusters. So you can play with the data and see where you get clusters.
Sir, I tried this PCA transformation that if I convert it into just two components.
No, don't do PCA, because after PCA it will be very difficult to analyze the data. Instead of PCA, just add some features from the data, not all the features. Add some
Okay, sir.
features. And
Okay.
this supervised label, the class label, remove class labels. Do it without class labels. But I believe you are doing that only.
Okay,
Are
sir.
you using class label in your register, or you are not using class labels?
Not using, sir. Not using class labels.
Okay.
Okay, sir. So I'll try and sir, I'll let you know. Ma'am, so can I stop presenting?
Yes, you may stop presenting now.
Okay, ma'am. Thank you.
Okay, so those of you who are still working on this, continue with your work, and we'll check your work after some time. That is maybe 20 minutes. After 20 minutes, I'll check your work, right? So let me know. Meanwhile, if you are facing any difficulty, just unmute yourself and you may ask, right? So, Prince, you have a question that whether to find the good quality of clustering algorithm using accuracy score or celluloid score. I think this score, celluloid score, is mainly used for finding the optimal number of clusters in your that what number of clusters you may use in your data set, and you may use accuracy score as one of the measure to find. Mostly it is for clustering. You want to find how good is your algorithm performing, so accuracy score is one of the measure, right? Are you getting the point? Yes. And regarding the evaluation, your work, you have to submit the link in the classroom. So uh, after adding me as a collaborator, you have to submit the link as well, right? So I think that is clear to everyone, right? Yes, Janil, what is the doubt? How the diabetes data set is showing the data? Uh, can you be more? Can you elaborate this doubt a little? I'm not getting the question. Yes, yes, unmute yourself.
So in diabetes data set, if I see the feature names for, as sir said that try for some, take some columns only, don't take all the
Yes.
columns. So
Hmm.
for that I'm seeing the feature names, and in that there is age, sex, BMI, and blood pressure, and all that it is given. So
Yes.
ma'am, in age column, the ages are, I think, how can a age be 0.03, ma'am? Like,
Okay. Did you see that you are not looking through the wrong labels? I think just go through. Just show me the code. Can you show
yes,
me the code?
1 second. Is it visible, ma'am?
Yes. Yes. It is
So,
visible.
ma'am, I'm printing these feature names, and
Yes.
for third row, I'm seeing this that age is minus 0.08, ma'am. So, how is it possible?
Okay.
Or
I think
rather,
this
they are
is.
scaled down, like scaled.
Yes. Have you performed the scaling?
No, ma'am.
Or
Because the data is already scaled, ma'am.
okay. Data is already okay. Well, do one thing. Just print the data part. Just the data that you have done the load data set. Just
Okay,
the
ma'am.
data one. Okay. Yes. So this is actually the feature array that you have, right? So this is the values that you have. Mm, and no, not that one. The one below that. See, the feature names are given: age, sex,
Yes,
BMI,
ma'am.
BP. Yeah, these are the features. And array is given to you. So these are the rows in the row form that the array is given to you, right? So can you see for the data 3 or something like that? Are you getting the value? I think you may have gone through the PCA data set that you have created.
No, ma'am.
Maybe
I
that you were
deleted that, ma'am.
observing.
I
You
deleted
have
that.
deleted that one? Okay. So you were trying to observe which one? X. Okay, just go a little up. Harsh, I'm coming to you. Yes.
So,
Go a little upwards. Oh,
yeah.
yes. So X is the data. So
Yes,
what is data? Just see the
ma'am.
data.
This one, ma'am.
Okay. I think that is a metadata or something like that.
No, ma'am. It is data means this is the X, ma'am. I mean,
Okay.
the things we passed, like features, ma'am. They are the features. These data are the features.
Okay. Just type data and try to execute. I would like to see
Yes,
what
ma'am.
is the output you're getting. Okay, this is the data. I see.
So, ma'am, as we saw that it was 0.08, so this one was that.
So this was the one you were getting, but
Yes,
instead of
ma'am.
that, actually what you're supposed to get is from the data itself. So
Ma'am,
see for
actually, I'm
data,
expecting that age should be. I mean, age.
yes,
It
yes,
should not have been scaled data because
right. Yes, I'm getting the point. So what you do is maybe try for data into bracket 3 and check what is the output that you're getting.
yes, ma'am.
Just in that case, be that. No, remove the data part. Yeah, okay, fine.
But ma'am, data.
Just for the data. Okay, remove that dot data. Yeah, just now.
It would give error, no, ma'am. It
Oh
is a
yeah, it will
dictionary.
give it. Yeah, fine. Okay. Hmm. But you are supposed to work with the data that is not this part, but with the actual part, right? With
Yes,
the
ma'am. So what I would do is in this age one, I would convert it like from 0 to 10, I would convert it as one label, then 10 to 20 another label. So that would reduce the number of. I think
uh,
that would work maybe. That's why, ma'am.
like how you are trying to say that. Why would you like to convert from 1 to 10 to one label and the rest to?
So, ma'am, it would be easy to. I mean, it would form the clusters. I mean, intuitively, it would form the clusters by itself,
But
like.
but
And after that
ultimately,
clustering algorithm,
yeah.
if I apply, it would be good, I think. That's why.
Okay, but what I would suggest that you directly go for the clustering algorithm. that whether a clustering algorithm is able to create that cluster by itself or not.
Okay, ma'am.
Are you getting? Okay,
Yes, ma'am.
just try that. Fine.
Okay.
Yes,
Thank-
Harsh. Yeah, Harsh, you may
Yes,
share the
ma'am.
screen.
Yes, ma'am. Ma'am, actually, here I was getting a error that X and Y are not of same size.
Okay, where is that?
In this PLT, that's plot dot scatter.
Okay, so what is the size? I think it won't be able to. Is this data two-dimensional?
Yes, ma'am. Because
Just
here,
show me. Yes, there are
yes,
four
this,
columns here. Four columns in your
yes.
input data set, and yes, show me a little. Go a little down. Just show me the
Okay,
scatter
okay.
plot.
Yes, yes.
So while what is data.test? What is the data.test?
That is for that in the 10 test split there. So that testing data is there. So I just tried to print it if it would be like possible. So, but it gave
Okay,
me
X
error.
and Y must be of same size. I
Yeah.
think this both are not of same
Not
size.
on.
So
Yeah.
check the size of both the data set that you are created, data test, and for both this one, right? So
Yes.
by -1, I think you are going for the last column only in that one,
Yes.
and
Yes.
for this, I think this is zero slash will create. Yes, okay. Syntax mistake. Somebody is saying, Ronak is saying there is a syntax mistake.
Okay.
Okay. Okay, check for this.
Okay. Yeah.
So Ronak
Comma.
was
Comma.
suggesting.
Comma. Comma. I
Okay.
forgot here.
Okay, check for that and try to update.
No.
Also in first one, I think data test you have not.
Yeah. Yeah. Why not comma? Got it.
Okay.
Yeah. It is done.
Yeah, fine. Now it is done. Fine, good.
Yeah. Thank you.
Okay. Yeah, thanks Ronak and Prince and Chandresh. Okay. Yes. Anybody else having any doubt? Fine. Yes, Janil? Okay, so what is this error? This is the error that you are getting after while applying the clustering algorithm on this particular data set? Okay.
Ma'am, actually, 1 second, ma'am. I'm sharing the photo. 1 second, ma'am. It is not coming in this way, I think.
Some access request, Janil. I've sent you the access request. Okay, so you have done the plotting of the data set like this, right? Hello, Janil? Yes. So your question is how to perform this clustering here, how to apply, but okay. Can you share the screen, Janil?
Yes, ma'am. One second.
Yes.
Ma'am, is my screen visible? Hello, ma'am.
Yes, your screen is visible. Yes.
Okay. Uh,
Okay.
so, ma'am, this is what I'm getting if I plot the data.
Okay. Fine. So did you try to select some of the features, or you are trying to use all of the features?
I'm trying to do that, ma'am. Right now, only I was trying to do. But, ma'am, in this, how? I mean, which features to explore, ma'am? Because
Okay.
as you can see, there are no kind of like hard and fast clusters that we can make from this. Like,
Yeah, I think that the point comes that maybe the data set issue is here. That this is not a good data set. So what you can do is maybe you can take a small set of features at this point of time and try to see that what is the observation that you are getting for that
So
particular
is this
feature set of features.
diabetes dataset,
Yeah.
Chanil?
sorry, yes, sir. Yes, sir.
So you can try sex and body mass index and see
Okay.
what kind of separation you get.
Okay, sir. Okay.
Okay.
But yes, this
And
is
I
regression
think
dataset.
Sorry, sir.
This is regression dataset. Yes. So ideally, this is for regression problem, but we are just trying to see like what kind of clusters we can form from that.
Uh, so, sir, should I mean, for that, sir, if even if there is low seal out score, it would be okay, sir.
Yes. So it means that you cannot do better than this. It's something like
Okay, sir. Okay, sir. Thank you, sir.
here. I think for these two features, you should be able to run clustering, I guess.
Uh, Sir, here also the both clusters could not be formed because they are intersecting each other, sir.
Mhm. And if you run, what happens?
Uh, I mean, we would not get, sir, good score. Like,
No, that's fine. So that's fine. So this is just we are trying to learn on this. So good score is
okay,
not an issue, but we are just trying to understand the data.
okay, sir. Sir, I'll try and I'll let you know, sir.
Yeah. Okay.
Thank you, sir.
Okay. Yes, Prince and Keval both have question. Just a minute, Prince. Okay. So you want to visualize multiple features data set to analyze the cluster. I think Janil must have used some of the any Janil. Do you have any idea which function? Yes, you used Seaborn to visualize this multiple features, right? So you may use that one to visualize this multiple features, right? Yes. Yeah. Okay, yes, Keval, you may unmute
Yes.
yourself.
Hello, ma'am. Am I audible?
Yes.
Yes, ma'am. Ma'am, my question is, I have performed this K-means algorithm on the Iris dataset, and in Iris dataset we have four features, and I'm getting the seal house score is about 0.68, but I want to I want to increase that score. So that means I want to reduce the features. That how many features I should take? That is my question. Like Sarah has just
Um,
said that please reduce the features and try to get the score. That's why.
no, score. I mean, so did you get the number of clusters? Silhouette score is for the number of clusters that you are getting, right?
Yes, ma'am.
So
Yes, exactly.
yes. So how many clusters did you get?
I have by using this K elbow visualizer, my optimal clusters value is a 2.
Okay. So so you want to what do you want to do now?
Just a minute, ma'am. I present and I show what I just.
Also, one thing. So when
Yes,
I
sir.
said reduce the features, the
Yes, sir.
intention was not to improve the clustering score,
Okay, sir.
but idea was to see that which data points can be separated, right? So when we are saying that
Okay,
something
sir.
is a clustering problem, the when we visualize the data, we should see some clusters, or there should be some separation between the data points so that you can
Yes, sir.
cluster.
Yes, sir.
So
Actually,
if
sir,
your
I have.
data set is not of that nature, then obviously clustering score would not be good.
Yes, sir. So that is at exact question, sir. If we reduce the feature, that means the score is not dependent on the numbers of feature, right, sir?
No, no, so that is not the point. Score and feature, they are not. It is not direct correlation that you reduce the feature and you get good score or bad score.
Yes, sir.
But we are trying to understand our data points, like which features are clearly separable into clusters, and which
Okay,
features are
sir.
difficult to separate into clusters. Okay,
Okay, sir.
trying to see when I
Ac-
ask channel to reduce two features.
Yes, sir. And sir, one more question is, if we have like four features and I want to choose only two features for this clustering, then and how to decide that which features to take?
So plot the features in two dimension
Yes, sir.
and see how well separated they are.
Okay, sir. Okay. Thank you, sir.
Who would like to go next? Vidit, Birwa, Smith.